Hey, yo, 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 yo. This is Mr. G. This is a video talking about one-step inequalities. This is part two. You should have already watched part one at this point, and if you have not, please go back and watch it. So, we're actually going to solve inequality problems this time. We're going to present their solution and talk about what they mean. So, inequalities are very similar to equations, except for instead of an equal sign, we have an inequality symbol. So for this problem right here, I have x plus 5 is all less than negative 12. So we've replaced the equal sign with an inequality symbol. So what I want to do is I'm still going to solve for x and get x by itself the exact same way I would is if this was an equal sign. So what I want to do is I want to look at and do my inverse operations and get the x by itself to figure out what the solution is. So I'm looking here and I have x plus 5. The opposite of plus 5 is minus 5. And whatever I do on one side of the inequality symbol, I have to do on the other side of the inequality symbol. Those cancel. I bring down my x. Super important that we bring down that symbol. And negative 12 minus 5 is negative 17. There's my solution. That means any number that for x that is less than negative 17 would make this a true inequality. I can pick a number less than negative 17, plug it in for x here, and see, well, is that true? So let's take negative 20, for example. If I take negative 20 and I plug it in for x, because that negative 20 is less than negative 17. So that is a solution to this inequality. So if I take negative 20 and I plug it in for x, I'm asking myself, is this a true statement? Well, negative 20 plus 5 is negative 15. Is negative 15 less than negative 12? Yes, it is. So I did it right. I'm good. My solution works. So now I am going to have to graph a lot of these. So I need to also make sure, and this is where that part one video is so important, that I'm able to graph them. I zoomed in on negative 17 on my number line. I don't need to start at 0. I do have to have an open circle, and because it's less than, I'm going to shade to the left, because everything to the left is less than negative 17. Let's look at this one below it here. So now I've got y minus 5 is greater than or equal to negative 7. So again, I'm just trying to get the y by itself, and I'm going to do the same steps as solving an equation. So to get the y by itself, I'm going to add 5, and I'm going to add 5 to both sides. I'm going to bring down that inequality symbol. A lot of us, when we were solving equations, didn't like bringing down the equal sign, but it is extra important now to bring down an inequality symbol so it's facing the right direction, the variable's on the right side, and it just keeps us very organized so that we don't have incorrect solutions. So I get y is greater than or equal to negative 2. So then I can graph that solution here at negative 2. Again, negative numbers on the number line run backwards. And then because it's or equal to, I have a closed circle and it's greater than. So I go to the right because everything to the right on the number line is greater than negative 2. Go ahead and try these last two. Okay, they're very similar. So try the last two, see how we do. So pause it if you haven't paused it already to try these. So y minus 3. So I want to get the y by itself. So I have 8 is less than or equal to y minus 3. So I'm going to do the opposite because I have to get rid of the minus 3 so I can get y by itself. So I'm going to do plus 3 on both sides. Those cancel. I'm left with y is greater than or equal to 8. So I know y is greater than or equal to 8 because the mouth is opening towards the y. So y is the larger number. So if I want to graph all the possible solutions, the reason why we graph it is we show the solution set. We show that we understand what this is actually telling us. So this is telling us that y is greater than or equal to 8. So I'm going to show that by showing that all these numbers over here that are greater than or 8 are part of this solution. If I plug in any number to the right of 8, on the number line, which goes on forever. So that means 9, 10, 100, 200, 17,000. All of those numbers, if I plug them in for y, it would make this, it'd be a solution to this inequality. And I'm showing that by the graph. And I'm showing that I understand what this means. Okay, and the last one, trying to get the x by itself. So I have to get rid of this positive 12. So because I want to get rid of the positive 12, I'm going to minus 12 on both sides. That cancels. X is less than, let's see, 9. So the x is the smaller number. X is less than 9 because the 9 is where the mouth is opening up towards. So I'm making my number line here at 9. Open circle and less than. So there we have it. Now, looking at these next three, we have a special rule here, and this is the part that is the one part that's any different than solving equations. This is the one little extra rule that changes a little bit of that changes inequalities just a tiny bit. And that is when you multiply or divide both sides by a negative, you must flip the sign. Here is why. Let's talk about a true statement here. If I said 2 is less than 3, this is a true statement, right? 2 is less than 3. If I added 1 to both of these, does it remain true? 3 less than 4. Yeah. So when we were adding and subtracting on both sides of the inequality sign, it maintained a true inequality. Let's say I multiply both sides by 2. Is it going to remain true? Well, then if I multiply both sides by 2, maintaining that, if I do whatever I do on one side, I do on the other, I get 6 is less than 8. This is still a true statement. So I was able to add 1 to both sides, kept it true. I was able to multiply both sides by 2, it kept it true. Well, let's see what happens when I multiply both sides by negative 2. So I multiply both sides by negative 2. Negative 2 times 2 is negative 4. 3 times negative 2 is negative 6. Is this a true statement? Is negative 4 less than negative 6? And the answer is no, it is not. But if I flipped my sign, it is now true. And that is because when we multiply by a negative, we're automatically going to change the sign of both sides. And so therefore, when we change that sign, it is not going to be a true statement anymore. So we have to flip it in order to maintain in order to maintain a true statement. So here's what that means. Looking at this, let's go over here to the second one real quick. I have negative 4x is greater than 52. Like we said, all the steps are the same as equations. So I am trying to get my x by itself. So because I'm trying to get my x by itself here, I need to get rid of this coefficient of negative 4. And the way I get rid of this coefficient of negative 4 is I divide it by negative 4. Because the opposite of multiplication is division. And whatever I do to one side, I have to do to the other. So these cancel. I'm left with x. And then I actually have to do 52 divided by negative 4. Well, that's 13. And it is negative 13 because a positive divided by a negative is negative. But what I had to do is I did have to divide both sides by a negative sign in order to cancel something out. So because I had to divide both sides by a negative symbol, I have to flip that inequality symbol to make it x is less than negative 13. And that's a one rule that it makes anything about inequalities different than equations. Everything else we do from here on out is the exact same. That's the one little extra. And then, of course, I would have to graph my solution to show that I understand what it is. Okay. So looking at this one over here. Oh, I'm sorry. When I graph it, open circle. Sorry, I had to pause and forgot to pick up where I left off. So graph it, open circle, because there's no or equal to. X is less than negative 13. So because x is less than, it shades to the left. Now for this one, I'm getting y by itself. This is y divided by 3. The opposite of division is multiplication. So I didn't multiply both sides by 3. Now I'm not multiplying both sides by negative because this isn't a negative. So because of that, nothing flips. I just bring down my sign, and I get y is greater than or equal to 15. I don't have to flip anything because I'm not multiplying anything by a negative. It only is when we have to do it by a negative. So I'm already done. I just get y is greater than or equal to 15. I can have a closed circle on 15 and shade to the right. Okay? And then finally, this last one here, pause it and try it on your own real quick, actually. I want you to pause it and try it on your own. Okay. So the negative sign is in front of the whole entire fraction, but we want to get rid of that negative, so the way we would do it is we would multiply by a negative. So I would multiply this by negative 6, and that would make this negative go away. So that goes away, and I can multiply the left side by negative 6. This gives me negative 42, and this gives me my variable by itself, but because I multiplied both sides by a negative, I have to flip my sign because I multiplied the right side and the left side both by a negative number. So I get t is greater than or equal to negative 42. So then, of course, I zoom in on my number line at negative 42, close circle, because it's or equal to, t is greater than negative 42, so everything to the right is greater than. Okay, that's it. So things to remember. Let's talk about our rule. Flip sign. Flip the sign when multiplying or dividing by a negative. Both sides. That's a place where the only thing that's different than equations. If you know how to solve equations, you know how to solve inequalities. The only place that's going to give you a hard time is flipping that sign. So if we can do that, we're golden. And that's it. That's all I got for you guys. Make sure you get the 2 independent practice problems done. If you have any questions, please let me know. Thanks for watching. G out.